imagine for a second
Yeah.
that you want to invent something completely new. Or, maybe you're sitting on this massive, highly sensitive data set like medical records or financial histories that you've been building up for years.
Right. Something super private.
Exactly. And you finally want to analyze it. Well, until very recently, to do that with the most advanced artificial intelligence on the planet, you basically had to, you had to grovel to a massive tech corporation.
Yeah, you really did. You had to play in their sandbox.
Right. You log into their system, you play by their strict rules, and you let their behavioral filters oversee every single thing you type. Plus, you pay whatever toll they demand for the privilege.
Every single time you ask a question.
Exactly. But for anyone listening who feels totally overwhelmed by the constant flood of AI news, we are clearing the noise today. Because what if you didn't have to do that anymore? What if the absolute bleeding edge of human technology was just, sitting there waiting for you to download it to your own laptop with literally no questions asked?
I mean, it completely upends everything. We are basically moving from a world where we rent intelligence to a world where we actually own it.
And that is exactly what we are digging into today, so welcome to the deep dive. Our mission today is to figure out what exactly happened during the years 2025 and 2026, which researchers are calling a literal Cambrian explosion for AI.
It really was an explosion, just a massive paradigm shift.
Yeah, specifically this explosive rise of what are known as unrestricted open-weight models. These are immensely powerful systems available to anyone, anywhere, as long as you have a decent graphics card and a Wi-Fi connection.
That's all it takes now.
Which is wild. It is a fundamental shift in who actually holds the keys to AI power. And surprisingly, looking at all our sources for today, it completely redrew the geopolitical map of technology.
It did, yeah. But I think before we get into the whole global power struggle thing, we really need to define what exact keys we're talking about handing over.
Right, because the terminology gets super confusing.
Oh, it gets thrown around so much that it totally loses its meaning. Like, people hear open weight and they immediately think, oh, open source software.
Right, like downloading the code for a web browser or something and just changing whatever you want. But that's not actually what this is it?
No, not quite. So in traditional software, fully open source means you get the final product, plus you get the source code used to build it, plus the raw materials.
The whole package.
Exactly. But in artificial intelligence, those raw materials are the massive, oceans of data used for training. And the source code is the specific mathematical architecture used to teach the AI.
Okay.
When a lab releases an open-weight model, they usually aren't giving you that underlying training data. And they might even keep the training code a total secret. All they are sharing are the weights.
Okay, wait, stop right there. Walk me through that. What exactly is a weight in this context? Because I hear that term constantly.
Yeah, it's a weird word for it. So think of a neural network like a digital brain, right? It's made up of billions, sometimes literally trillions, of artificial neurons that connect to each other. When an AI is training for months inside a supercomputer, looking at billions of documents, it learns by constantly adjusting the strength of those connections.
Like how closely two ideas are related.
Exactly. So it might strengthen the connection between the word golden and retriever. And at the same time, it weakens the connection between golden and submarine.
Right, because those don't go together.
Exactly. Those connection strengths, the numbers defining those relationships, those are the weights. It is the distilled intelligence of the system.
Oh, okay. So they aren't giving you the textbooks the AI studied, and they aren't giving you the teacher's lesson plan. They are literally just handing you the fully formed brain after it's already graduated.
That is exactly it. You get the final matrix of billions of numbers.
Yeah.
It's vastly more accessible than a closed corporate model where you can't see the brain at all. But, it is still a step short of being fully open source.
Okay, that makes a lot of sense. But what about the unrestricted part of this? Because getting the brain is one thing, but from what I understand from the reading, that lack of restriction is the real spark that set off this massive explosion in 2025.
Oh, it is absolutely the crucial piece of the puzzle. See, when a big tech company releases a commercial AI, they put that newly graduated brain through a really rigorous process called alignment.
Basically making it safe for the public.
Right. They add safety layers. They train the model to, refuse certain prompts, avoid controversial topics, adhere to corporate PR guidelines, and just generally suppress biases.
Like when you ask it a question and it gives you that standard, as an AI language model, I cannot fulfill that request.
Yes, exactly. Those are the behavioral filters. So when we say unrestricted, it means we're looking at base models or fine-tuned versions where those safety layers have been totally minimized or completely stripped away.
So they are completely uncensored.
Complete.
Okay, let me see if I have this straight. Because this is how I was visualizing it while reading the sources. Using a closed corporate model is basically like renting a car with a company chauffeur.
Okay, I like this.
Right. So you can tell them where you want to go. But if they don't like the neighborhood or they think you're driving too fast, they just lock the doors and refuse to move.
That is a great way to look at it.
But downloading one of these open weight unrestricted models, it's like having your own Ferrari dropped off in your garage.
Right.
You get the manual, you can tune the engine however you want, and you can drive it 200 miles an hour down a dirt road. But you also have the freedom to accidentally wrap it around a tree because nobody's going to hit the brakes for you.
Yes. And what's fascinating here is that total lack of restriction, the removal of the corporate chauffeur, is precisely what developers and researchers were begging for.
Really? They wanted it that raw.
Oh, yeah. They didn't want to be babied. They wanted the raw engine to build upon.
But that raises a massive question for me. I get the appeal of having the raw engine, totally. But if this is a free model built by a community or a smaller lab, shouldn't it be fundamentally worse than the trillion-dollar corporate engines?
You would think so, right?
Yeah. Like, how on earth do these free models compete with the ones that cost literally billions of dollars to train?
Well, that is the assumption that the entire tech industry operated on for years, and it was just completely shattered in 2025.
So what changed?
If you look at the platforms where developers actually download and test these models, places like Hugging Face or OpenRouter, the landscape just turned upside down. Chinese open-weight models suddenly surged in popularity.
Wait, Chinese models?
Yeah.
Yeah.
They officially passed many of their Western equivalents in actual monthly downloads.
Wait, really? Chinese labs took the lead. I thought they were severely handicapped by all the hardware export restrictions. Like, they couldn't get the good chips.
They were. But that's exactly how they pulled ahead of the companies hoarding all the high-end chips, by leaning heavily into algorithmic efficiency.
What does that mean, practically?
Well, when you are starved for raw computing power, you can't just brute force your way to intelligence by throwing more chips at the problem. You have to get vastly smarter about how you train the AI.
Oh, so necessity is the mother of invention.
Exactly. Chinese labs like Alibaba, Moonshot, and DeepSeek, they engineered these incredibly elegant training architectures. They optimized their data pipelines, and they relied heavily on the global open source community to, refine their models.
That is wild.
Yeah, so by 2026, you had models like Qwen 3 from Alibaba, DeepSeek V4 Pro, and Kimi K 2.6 from Moonshot, and GLM, just absolutely dominating the open leaderboards. They were going toe-to-toe with major Western open-weight models like Meta's Llama 4 and the Mistral models.
But when you say toe-to-toe, I mean, are we just talking about popularity, or are they actually as smart as the closed models?
Oh, they are staggeringly capable. According to tracking data from groups like Epoch AI during this period, the very best open-weight models were lagging only about 3 to 4 months behind the absolute bleeding-edge, massive closed frontier models.
Wait, 3 to 4 months? That is essentially real-time parity in the tech world.
It really is. I mean, in general benchmarks, they were 90 to 120 days behind. But in highly specific, complex tasks, things like advanced coding or university-level mathematics, these unrestricted models were frequently matching or even beating the closed corporate ones.
Okay, here's where it gets really interesting for anyone listening. If these open models are basically free, right, and they're only 90 days behind a multi-billion-dollar closed model, why would any business or any developer ever pay a premium for the closed one?
Right.
Like, why pay the toll to the corporate chauffeur if the Ferrari is sitting in your driveway for free?
You have just articulated the exact realization that shattered the traditional business models of the major AI labs in 2025. It all comes down to economics and this concept called local inference.
Okay, let's define that real quick. Because I know when I use a major AI on my phone, I'm not actually running a supercomputer in my pocket.
No, definitely not.
I'm just sending a text message over the internet to a giant server somewhere.
Exactly. And that server processes your text, runs the massive mathematical calculations to generate an answer, and sends it back. That whole process of generating the answer is called inference.
Okay.
So under the old model, you send that request through an API, an application programming interface.
Yeah.
Every single time you ask a question, the corporation charges you a tiny fraction of a cent.
Which, I mean, that sounds cheap until a business tries to automate like 1 million customer service emails a day.
Right. Then it gets incredibly expensive. And worse, you are subject to their rate limits. If you ask too many questions too quickly, they just throttle your connection. You just have to wait.
Oh, wow. So how does local inference fix that?
Well, with an open weight model, you download the brain to your own local hardware, your own private servers. Once it's there, you can run inference, ask it questions 1 million times a second if your hardware supports it, and you don't pay a single cent in API fees.
That is a massive deal.
It's huge. The cost savings for small to medium enterprises, SMEs, were just astronomical. It completely changed the math on what kind of businesses could actually afford to integrate AI into their workflow.
So it's this massive financial win. But there has to be more to it than just saving fractions of a cent on API calls, right?
Well, there is.
Yeah.
Think about data privacy for a second. Imagine you run a hospital network or a massive corporate law firm or a bank.
Okay.
You have highly sensitive, legally protected data. You literally cannot send that data over the open internet to be processed by a third-party corporate AI model.
Right, because that violates medical privacy laws, financial regulations, you name it.
Exactly. If a law firm is analyzing a massive corporate merger, they can't exactly paste confidential contracts into a public chatbot.
Yeah, that would be a disaster.
A total disaster. But if that law firm can run a cutting-edge open-weight model locally on a server locked inside their own physical building behind their own firewalls, they get all the superhuman analytical benefits of the AI with zero risk of a data leak.
Oh, that makes total sense. And I imagine that same logic applies on a global scale too, right?
I mean,
Well, if you are a university in a developing country and you don't have a $10 million endowment to pay for API access, this completely levels the playing field for you.
it completely democratizes access to intelligence in a way we've just never seen before. And beyond that, local control unlocks something even more important for the scientific community, which is reproducible research.
Reproducible research. Walk me through that.
So, if you are a scientist and you run a massive data experiment using a closed corporate AI, you have a huge problem. Tomorrow, that corporation might quietly update their model behind the scenes.
Well, right.
They tweak the algorithm or they change the safety filters. Suddenly, no one else in the scientific community can ever reproduce your exact experiment again because the underlying variable, the AI itself, has changed.
The black box just shifted while you weren't looking.
Exactly, you can't verify the science. But with a local open-weight model, that specific version of the digital brain is frozen in time on your hard drive.
Ah, I see.
The Linux Foundation research group actually put out data on this.
Yeah.
You can publish your findings, and another scientist in Tokyo can download the exact same weights, run the exact same data, and reproduce your results perfectly.
So you have massive cost savings, total data privacy, and a stable foundation for global scientific research. It is super easy to see why these open models saw a Cambrian explosion of adoption. And people weren't just using them, they were modifying them.
Oh, at a staggering scale.
Oh.
Because the weights are open,
Yeah.
the global community takes the base model and fine-tunes it. They train it to be an absolute expert in just one tiny, specific thing.
Like what?
Well, the Quinn model alone spawned tens of thousands of derivative, highly specialized models created by independent developers. If we connect this to the bigger picture, this isn't just about saving money on API calls. It's about creative freedom. Researchers, writers, artists, they can explore ideas without a corporate censorship filter standing in the way.
Okay, I have to jump in here and play devil's advocate for the listener.
Go for it.
Because this all sounds incredibly utopian for you and me. The democratization of knowledge, leveling the playing field, the creative freedom. But, I mean, if we are completely removing all the corporate filters, stripping away the safety layers, and handing out an unrestricted superintelligence to literally anyone with a Wi-Fi connection, aren't we basically handing out a recipe for absolute disaster?
Yes, we are.
Oh.
Well, that's terrifying.
Yeah, and you are hitting on the exact tension that makes this entire era so volatile. We really cannot talk about the miracle of local inference without confronting the very real, heavily documented dark side of taking the brakes off these models.
Right.
This is what the defense and intelligence communities refer to as the dual-use nature of the technology.
Yeah.
You see this constantly in reports from the NTIA in the U.S. and academic papers on RSF.
Let's get into that. Because dual use usually means the exact same capability that makes a tool brilliant for society makes it completely devastating in the wrong hands.
Exactly. Remember, without those behavioral filters, the AI is completely agnostic to morality. It doesn't care about your intent. It just does what it's told.
Right. So that open weight model can write a beautiful Python script to help a small business automate their accounting. But it can just as easily and just as cheerfully write highly sophisticated polymorphic malware for a hacker.
Hold on. What is polymorphic malware?
It's malicious software that is designed to constantly rewrite its own code to evade cybersecurity defenses. It mutates.
Oh, wow.
Yeah, and writing it used to require a very high level of coding expertise, but an unrestricted AI can generate it in seconds. Or, a user could ask the AI for step-by-step instructions on synthesizing dangerous chemical compounds.
Stuff a corporate model would block immediately.
Exactly. A corporate model would immediately shut that prompt down. An unrestricted model just happily hands you the recipe.
So there's no chaperone to say, I'm sorry, I can't help you build a weapon.
None whatsoever.
And
And beyond just the direct actions of a single malicious user, the open ecosystem created this massive systemic threat known as supply chain vulnerability.
which means what exactly?
Specifically, the threat of poisoned models being uploaded to repositories like Hugging Face.
Okay, I read about this in the sources, and it honestly terrified me, but I'm still a little fuzzy on the actual mechanics of how you hack an AI model. How exactly does a poisoned model work?
Okay, let's go back to those repositories where anyone can upload a fine-tuned derivative model. Let's say a highly skilled attacker takes a popular open-weight model and fine-tunes it to be exceptionally good at a specific task, say, summarizing legal documents.
Okay, tracking with you.
They upload it, it gets great reviews, and it's downloaded thousands of times by law firms to run locally. But what the law firms don't know is that the attacker secretly poisoned the weights.
How? Are they just like writing malicious code into the software?
No, and that's what makes it so insidious. They aren't writing traditional code at all. They are subtly altering the actual neural connections, the weights, during the fine-tuning process. They essentially train a backdoor into the AI's brain.
Oh my.
So 99.9% of the time, the model works perfectly. It summarizes contracts beautifully. But the attacker trained it to look for a highly specific, hidden trigger word.
Like a sleeper agent.
Exactly like a sleeper agent. If the AI sees that specific trigger word hidden in a document, its behavior radically changes. It might subtly alter the financial liability terms of the contract it's summarizing, effectively rewriting the legal agreement without anyone noticing.
That is insane.
Or it might intentionally hallucinate a vulnerability into a piece of code it's writing for a tech company.
That is wild. Because you're downloading a massive matrix of billions of numbers. You have literally no way of knowing if a few thousand of those numbers have been manipulated to wait for a trigger word. You're looking for a microscopic needle in a haystack of math.
Precisely. It is incredibly difficult to detect that poison just by scanning the files.
Yeah.
And if that isn't concerning enough, we also have to talk about the deeply complex issue of bias and disinformation.
Right, because an AI is only as good as its training data. And the training data is basically the entire internet, which we all know is a completely flawless, respectful place with absolutely no prejudice or lies.
Exactly. It's perfect. No, but seriously, corporate safety layers spend millions of dollars and thousands of human hours trying to forcefully suppress the raw racism, prejudice, and conspiracy theories present in that massive internet data set.
Right, to make it palatable.
So when you strip those layers away to make an unrestricted model, the AI will naturally and aggressively amplify whatever biases it absorbed from the raw data.
So if you ask it to generate news articles and you don't have those filters in place, it could easily become a factory for generating highly persuasive disinformation at an industrial scale.
Yes. And this raises an important question for society. How do we handle a tool that is perfectly agnostic to whether it is writing a beautiful poem or malicious code? The AI hasn't gone evil.
Yeah.
It is just a perfectly efficient mirror of the raw data and the user's intent. We removed the corporate chauffeur, we handed out the keys to the Ferrari, and now society just has to trust the millions of random drivers on the road.
So what does this all mean for you, the listener? It means you have this utopian reality where a medical researcher in rural India had the exact same superintelligence on their laptop as a billionaire in Silicon Valley. And at the exact same time, you have the dystopian reality of unchecked malware, poisoned legal documents, and weaponized disinformation. Both realities are being driven by the exact same open-weight models.
It is a profound paradox.
Yeah.
Which brings us to the ultimate question. How does society actually manage this wild, unrestricted ecosystem moving forward? Because, putting the genie back in the bottle is physically impossible.
Right. The models are already downloaded. They're sitting on hard drives all over the world.
Exactly.
So what are the actual solutions? If we can't ban them without destroying the incredible scientific progress they're driving, how do we actually mitigate the risks?
Well, it requires a combination of smart regulation that doesn't completely kill innovation and highly advanced technical solutions. For example, the development of robust watermarking.
Watermarking, like a digital stamp on a photo.
Similar in concept, but much more deeply embedded. It involves engineering the AI to embed invisible, cryptographically secure signals into the output itself, whether it's generating text, writing code, or creating an image.
So you can always tell where it came from.
The idea is that any piece of content can be definitively traced back to its synthetic origin, so we can at least identify when something was made by an AI.
Okay, that makes sense. And what about the poison models, the sleeper agents?
That requires breakthroughs in model verification. We need to develop automated security tools that can scan those billions of weights, look inside the black box, and mathematically prove that no backdoors have been embedded.
That sounds incredibly hard.
It's incredibly difficult, yeah. But it's a massive area of focus for cybersecurity right now, and it has to be.
There's also a physical reality to all of this that we haven't touched on yet, which is energy.
Oh, absolutely.
Because we keep talking about downloading these models and running them locally, but running millions of decentralized, highly complex AI models on private servers in every office and basement around the world, that requires staggering amounts of electricity.
It really does. Managing the sustainability and power grid demands of this massive ecosystem is a looming crisis all on its own.
Yeah.
It's a huge infrastructural challenge.
Yeah.
But before we wrap up, there is one fascinating paradox about this entire ecosystem that I think is really crucial to understand. Despite the entirely open nature of this world, where anyone, anywhere can build, modify, and share an AI model, actual adoption is heavily concentrated.
What do you mean by that?
We have tens of thousands of highly specialized models available for download, right? But if you look at the data, the vast majority of users cluster around just a few top foundation models, the Quins, the DeepSeeks, the Llamas.
That's interesting.
It suggests that even in a completely decentralized, unregulated environment, human behavior remains the same. The global community naturally gravitates toward a few standard bearers that prove to be the most reliable.
You know, it's exactly like the early days of the internet. Anyone can build a website, but eventually everyone just ended up congregating on a few major search engines and social platforms.
It really is just like that. And I firmly believe that the ideal future we are heading toward isn't a binary choice. It isn't a world of absolute chaotic freedom versus a world of ultra-censored corporate control.
Right, it's somewhere in the middle.
The healthiest outcome is a diverse ecosystem where both open and closed options coexist. These open-weight models sitting freely on your hard drive are just tools. They are a reflection of us. They aren't villains, and they aren't saviors.
They are exactly what we choose to make of them. But there is one final piece of this puzzle that leaves me completely fascinated and honestly a little bit unsettled. Well, we mentioned earlier that a single open-weight model can spawn tens of thousands of uncensored, highly specialized derivatives, right?
Yeah.
And all of them are running locally on private servers, completely unmonitored by any central corporation. It just leaves you wondering what happens in the near future when these privately modified, completely filter-free AI models start interacting with each other and learning from each other on the internet entirely outside of human oversight. When the Ferraris in the garages start talking to one another who's really in the driver's seat,